All right, well, I hope everybody had a great weekend and is having a good Monday. Also, hoping my dad does pretty well in his round of Wheel of Fortune, and maybe I'll get a little TV time. We'll find out though. But I will be back in school tomorrow as long as my flights work out and I get home in time. But today we're going to work on graphing absolute value functions. We're going to start off with the parent function, f of x equals the absolute value of x. In case you don't remember, absolute value means the distance from zero. And so since it's distance from zero, it's always positive. And so we'll start off on the first one. We'll put it in the calculator. And then the rest of the time, I'm not going to put anything in the calculator, but if you ever need to, you can always go to the calculator. To find absolute value, we're going to go to this f2 up here. And so alpha f2, absolute value is that top function. There are a couple other ways to find absolute value. This is the one I'm going to consistently use, though, in class. So we're going to do the absolute value of x. There's what it looks like. It makes that v. In my table, I'll just use a few points. I'll use -2, -1, 0, 1, 2. The absolute value of -2 is 2, -1 is 1, 0, 1, 2. Absolute value always comes out positive, so an absolute value of -2 is +2, absolute value of +2 is +2, and it always comes out positive. And so we'll plot these points and then connect my graph. All right, so there's my V right there. Looking at this absolute value graph, the domain goes forever left and forever right, so all real numbers. My range starts at 0, and it goes all the way up to infinity, and it includes 0. One thing I do want to go over on this graph, or what I'm going to call base points, it's how without a calculator we're going to get all of our future points, so we don't have to continue putting in the calculator. And if you're good at doing without a calculator, you're going to get your homework done a lot faster this way. So our base points, and it's always starting at the starting point. And so from the starting point, if I were to go right 1 from the starting point, I go up 1. If I go right 2 from the starting point, I go up 2. If I go left 1, I'm going to go up 1, and if I go left 2, I'm going to go up 2. These are my starting points, and these points will always be the same for every single absolute value function graph unless there is some sort of number in front of the absolute value that will reflect over the x-axis or vertically stretch it or vertically compress it. But we'll get there in a little bit. All right, so on number 2, I'm going to list my transformations first. X minus 5 is going to go right 5, and plus 2 is going to go up 2. And so my domain, since it was all real numbers, it still will be all real numbers. I'll go ahead and do the domain and range first. If you wanted to, you could graph it and then do the domain and range. Either way is fine. My range, it did start at 0. This time we're going up 2, so it's going to start at 2 and go up to infinity. And now for my graph. My starting point has moved. Instead of starting at 0, 0, we're going to go right 5 and up 2, 1, 2. There's my new starting point right there. Since there's no stretch or compress in the front or reflection, all my movements will be the exact same as my original starting point. So from my starting point, we're going to go right 1 and up 1, right 2 and up 2, left 1 and up 1, left 2 and up 2. And so it's the exact same V. It's just been moved right 5 and up 2. All right, on number 3, this time we've got a change in the front, so we're going to have a reflection over the x-axis. We're going to have a vertical stretch of 2, and we're going to go up 1. So my domain is still all real numbers. It's all real numbers every time for absolute value. My range, though, has changed. Since I have the reflect over x, it's now going to be opening downward, which means we're going to start at negative infinity, and we're going to go up 1, so it's going to go all the way up to 1. That's going to be the highest point. All right, so from 0, 0, the only movement we have is up 1, so this is my new starting point right here. However, since we have the reflect and the stretch, it's going to change how we're going to move from here. So I'm going to write down those base points again. When we went right 1, we did go up 1, right 2, up 2, left 1, up 1, left 2, up 2. But now since we have a vertical stretch, it's only going to affect the vertical component, which is this one. These are going to stay the exact same, but we're going to multiply all these numbers by this vertical stretch and the reflection. And so times -2. When you multiply by the negative, it's going to flip it. So instead of going up, we're going to go down, and 1 times 2 is 2. We're going to go down, 2 times 2 is 4. We're going to go down 2, and we're going to go down 4. And so all of these are from the starting point. So from the starting point, we'll go right 1 and down 2, right 2 and down 4, left 1 and down 2, left 2 and down 4. And so from the starting point, the left and right didn't get changed, but the vertical component did, and it doubled. Since the vertical stretched by 2, instead of going down 1, we went down 2. All the vertical components were multiplied by 2. All right, so there's my new graph, and just to check, my domain is all real numbers. My range does go from -infinity to +1. It checks. All right, going on number 4, we have a vertical compression this time. And so it's going to get a little wider, left 4 and down 3. My domain again is all real numbers. It does open up still, there's no reflection, and it goes down 3, so we're going to start at -3 and go all the way up to infinity. And so my starting point from 0, 0 went left 4, 1, 2, 3, 4, and down 3, 1, 2, 3. On this one, and you don't have to make this table every time. As you get good at this, you can just do this in your head. But I'll continue to make the table since this is our first time to do it, and we're making these notes. Whoops, I did the wrong arrow right there. All right, so on this one, we have a vertical compress of 1/2. So we're gonna multiply again, it's a vertical, so it's gonna change all these vertical components by 1/2. We still will be going up though, so we're gonna go up 1/2. We're going to go up 1, up 1/2, and up 1. And so from the starting point, I can go right 1, up 1/2. From the starting point, I go right 2, up 1, left 1, up 1/2, and left 2, up 1. So there's my graph, all real numbers, starts at -3, goes up to infinity. There's my domain and range as well. All right, number 5, it's gonna give us the transformations, and we're gonna build the equation, kind of like what we did in Unit 1 as well. So we're starting with the absolute value. We're gonna reflect across the x-axis, so f of x equals, we're gonna have a negative in front, stretch by a factor of 3. I should have put a v in here, vertical stretch. We're gonna put a 3 in front of the absolute value. We're going to shift left 4, so x plus 4, and down 1 minus 1. There's the equation. On number 6, again, absolute value. We're going to have a vertical stretch. I should have put that in there. So vertical stretch by a factor of 2. We're going to shift right 3 and down 6. And that's it. That's what we're doing on this next part. And then number 7, it gives us a graph, and from the graph we need to build the equation. And so from this graph, I'm going to go ahead and list my transformations. It's going downward, so it's going to have to reflect over x. The starting point, let's see, from the starting point we go right 1, down 1, right 2, down 2. So there's no vertical stretch or compress. We do just like we did on the graphs previous. You always look and see, does it go right 1, down 1? Yes. And so no stretches or compresses on this one. But my starting point has shifted 1, 2, 3, 3 left, and 1, 2, 2 up. And so we're going to have a negative in front of the absolute value. We're going to have x plus 3, and we're going to go up 2. And one thing you can always do if you wanted to, you could put this in your calculator and see, does it look like this? And if it does, then you are correct. If it doesn't, you may need to make some tweaks. But hopefully this makes sense, and I'll be back tomorrow just to check to see how you did. Hope everybody has a good day.